only case of three here. All right, it is 12:30, so I think we're in time to go. Um, Welcome everybody. This is the Anima working group at IETF 113 hybrid. If that's not what you're expected to, you're in the wrong room. So there were a bunch of new wonderful slides about the hybrid experience we're having here, but I'm guessing that given how this is the last session of the week, if we haven't figured out how to do it by now, it's probably too late. The one thing that's always very much appreciated for the people in the room, when you step up to the microphone before that, please, click on raise the hand so that the remote audience will also see your name in the queue. I think that's the most important one. Otherwise, standard procedures, IETF note well, everything is public, and there are a lot of interesting BCPs when you can't sleep that you should be aware of. Right, logistics, I think there is nothing of importance here. We've got a note taker, but it's also everybody else who wants to help taking the notes. Please go to the Hedgehog document and help with it. So let's go through some of these reminder slides here that I hope are always useful. We've got the early IPR disclosure process. So by the time that we're adopting a document, we're already asking the IPR question so that we're not surprised later on about a possible IPR in a document when we try to offload the document to ISG to become an RFC. We also now have 8 RFCs, so especially for the folks amongst you that are implementing either of those, when you find any bugs and problems, of course, raise them with a list, but specifically when they're against the text. We have an errata system in the IETF that allows you to track any such textual issues, and when you are implementing, you obviously also want to read the erratas of those RFCs in case they do impact the implementation, which I think a few of them do. So now let's get through the actual working documents that we have. So the first one, the oldest one, is the ASA guideline document. There is no slot for it. I think the main author is well asleep in New Zealand right now, and it is an auth 48 for 45 days. So I think that leaves it 3 more days. No, kidding. But yeah, it should be an RFC pretty soon, and I'm not aware of any issues in the auth 48 process left. So that brings us to ongoing work. Brusky Cloud, we've got a slot for it.
You are actually misleading people for the 48. It was 48 hours rather than 48 days.
I'm sorry, that was a badly explained joke, but yeah, it's actually meant to be 48 hours, but we are seeing a large variation of how long auth 48 takes. So that number of days is actually not really untypical for how long that stage of the process takes. Sorry for reminding me that that joke should have been explained. All right, then, so I've been trying to track, where work actually happens. So you'll see that most of the working group documents that we have been doing good work, and we're having slots for them. So no need to mention that in more detail here. What's specific? So we've got the constraint join proxy that is in the process of being submitted to ISG. So I think the current state is AD review. So that's hopefully going through well. We'll hear in the slot. We've got the Brucey Assing and role where there will be a name change coming up. That's the unusual thing about that one. We've got Brusky PRM that all of those are talked in slots. We've got the constraint voucher where in the last IETF we felt we needed more early review from the broader community. I'm going to talk about that separately in general, but that has happened very nicely since IETF 112. We've got the JWS voucher, standard ongoing. Now we have grasp distribution. I talked with the authors, and there is no slot here for this one. The Shepherd has done an extensive review since the last version, and the authors are working on a reply, but they couldn't come to the IETF this time around, so that's why they didn't request a slot and didn't hurry with their update to meet the deadlines for this IETF. So hopefully we'll talk about that one in Philadelphia. Then we got the
update as co-author for this draft. We are running well. We only receive very minor comments, and that would be addressed very soon. So we feel there's nothing major to report.
Yeah, I think the major part is really the Shepherd review. So I think that would be the major, I think, feedback to take into account.
Sure, will do. Okay.
Right. So one thing that slipped through the cracks, Michael, the voucher delegation, that's expired. Nothing for it. So it's just kind of in the whole list of priorities, just at the bottom end. All right. So let me just quickly take a note on that one. Voucher delegation. It's just low priority versus the other working group drafts. Okay. Right. We've got the RFC 8366 bis. And finally, we've got the service auto deployment, and also the authors for that one couldn't come to the IETF, so no slot for that one.
Terrace, you must miss something here.
Okay.
The authors did request slots, and
Really?
they upload the slides as well.
Well, okay. Let me see. Is that, am I infrastructure? Access?
Yeah, the slides number 7.
7. Oh, okay. Right. So that was a mismatch on my side. Okay. I'll have to fix the agenda slide and upload the fix to the agenda slide. Let me do a TBD.
Yeah, hopefully we
that was just
should have enough time.
Yeah. Yeah. Sorry for that. That was my mistake with the shared slides. Okay, so that's the main work. I'm not going to mention here in the share slides the non-working group items that we have on the agenda. Just let me quickly finish and get to the real work. So one of the ongoing issues, please, especially when you're an author of a document in the working group, mutually review other working group documents to help the working group to really do its job and move forward. And if you're not sure which document would be good for you to review, just ask us chairs, and I will be happy to help doing that. Also, the process that you saw after IETF 112, where we as the chairs are helping to get the formal early reviews from other groups in the IETF, like working groups and directorates, to happen, so that we don't overload the last call and ISG review in the end, but that we do it during the working group stage as good as possible. Shepherding is another way on how you can show your appreciation of the fact that you're going to be an author of an RFC when it's finally through. And so we haven't really made much of progress since IETF 1112 with these documents here that all still don't have Shepherd. So I guess we as working group chairs are going to reach out more to the authors of the different documents to help more mutually in the coming month, as appropriate, seeing which of these documents are far enough in the process that a Shepherd would really be helpful. Yeah, technical discussions. So yes, these working group meetings are always overboarding with process status updates, but that's just the cost of doing business in an organized fashion, and it's not the only way on how we can do work. The real work happens typically on the mailing list, and it can also very nicely happen on regular site meetings, interims. There are a lot of options. What has worked best for Anima so far is the what we informally call the Brusky Design Team weekly meeting. Michael is responsible for setting that up. I hope the time that I have here is the correct one, but otherwise, if it's not the correct one, I'll be happy to work with Michael that we send up. It's half an hour later. Okay. Update slot 4 weekly Brusky meeting. Send out to list. Okay. Right. So that's another TBD for me. We'll send an update for that. Also, we do have a GitHub. It's great, especially when you want to collect and structure any feedback that you're getting. One of the most easy things to make sure that any concern you have about a document doesn't get lost in mailing this discussion is to open up an issue in the GitHub entry for that particular document, and that's already a good enough reason that all of the Anima documents should have a GitHub entry. I think so far that is true, because it is great for tracking any issues better than the mailing list alone. But obviously, any real issues should always go to the mailing list, but tracking is very nice on GitHub. And I think that's it with process. So who would like to step up first to the microphone? We have, I think, Michael here listed for the status update on the constrained voucher and the hackathon that seemingly has happened for it. Okay, let me maybe stop share the slides, and
it worked before.
I can find the slides here. Constrained voucher.
This is amazing. It's amazing. We can have now, you know, we can have a slide clicker that works over the internet. Right. That's the major accomplishment of
Okay.
this year.
So how
right,
do I make
on the internet?
Where do I click so that you can control?
Find my name.
Okay.
Hover next to it.
Okay.
And you see that third button?
Okay.
No, that's the wrong. Yeah. Yeah.
That's
there
my
you go.
control.
That's
All right. So I'll lie
Yeah.
back and drink a bad coffee.
That's right. Here you go. Yeah, please. Okay, so the constrained voucher document is actually it's at 16. I'm sorry, I think it's at 16, not 15. Panos, Esco, Peter, and I, you know, this is I really like this big duck. It's really nice. But a little bit about it. I mentioned brusky.org before. I'll mention it again. And but constrained voucher is RFC 8995 re-implemented in terms of COSI and CBOR over DTLS using COAP. So take all of the regular big protocols and replace them with constrained ones, and that's what you get. Since 1112, there's a URL. If you have the slides, you can see the thing. Many small edits. You'll see there's, I think I counted like 17 or 18 diffs or something like this, and most of them are one-word changes. We fixed and validated all of the examples. We realized that one of the things we had wrong, and actually my code is still wrong about, is the assertions map. I map them to strings, which is wrong because there's no reason to send that many bytes. But Piang doesn't actually do the mapping for you, so we've actually put a table in the document which does that. We've not made it an IANA registry because in order to change that thing, you would have to go back to the Yang part and extend it. And there's an interaction there with the RFC 8366 BIS work there too that we'll come back to. We have tried to do interop efforts, okay. We were most well organized last summer when we had a week-long interop and we got some real work done during that process. The IETF has set up, the hackathon efforts has set up a layer 2 VPN. Initially it was a Raspberry Pi requirement, and then it became a micro tick box requirement. And at least 2 of us are now able to run that regularly. Mine just is running. You can ping it if you like. Peter turn it on and off, and we can do things. The reason why that's useful to us is because, of course, we have a discovery protocol that runs over L2 and needs multicast, and that actually works over the VPN, so we can actually test that. We have not yet done that because there are other things that have gotten in the way. And I would say the biggest problem is probably time zones, just getting everyone to say, okay, I'm going to work together at this time. And it's not always convenient for everybody. But we're continuing to do that, and we're very open to more people joining this, and the VPN, the IETF VPN makes it really easy to do. And particularly if your lab is behind 3 layers of, corporate firewalls or something, then the box might actually let you, have a LAN that's effectively not behind their control. I'd ask first, though. So there you go. What are the issues? So we actually still have an early allocation that request that I think that we should emphasize. I guess, we've used 6502, which is a private use value, and we need to come back, and Mr. Chair, and please can we do this early allocation on this, because that would be useful to do. And then we'll have to fix our code to actually support both for a little while and come back to that. That's just for the content format on the CoAP, right? On that request. So it's not super critical, but it's just annoying. I happen to run multiple Massa instances in a multi-tenant situation where you must have the SNI set properly to get the right web server. So this is probably a good thing that I have been so stingy as to not, they run on separate IPv6 addresses, but they use the same IPv4 address. I could have gotten another IPv4 address, but I didn't really care about that, about v4. So the SNI must be set correctly, or you won't get to my correct server. And so that's kind of useful, because it turned out it's revealed a number of bugs in a number of other clients that otherwise were not revealed by other instances. So that is, there's whatever it's called, that draft, use it or lose it kind of thing. It's kind of useful. I still haven't quite got the authority key identifier correct in the IDEV ID. And this has been a source of interop issues. So we're still kind of working on that. That's actually really goes back to RFC 8995 and voucher even to have that right. We're going to figure that out, going on, because it's getting in the way of things. So those are kind of the issues. It would be nice to have everyone come to Philadelphia and be in the same room and not have any distractions. So that, I think, is the major advantage of being in person. And the major disadvantage, of course, is that when you find a bug, it might take you 12 hours to fix it, by which point the hackathon is over, right? So that's the downside of not doing that. And that's really it. Any questions or whatever thing? The document is really ready for working group last call or additional reviews. There's some feeling that the examples maybe aren't proven to be correct until we've all interoperated successfully with all of them. But at this point, I feel actually that's probably boiling the ocean. They're probably good enough at this point. So, and we'll resume meeting in April. Not next week, but the week after. Thank you. Let me see. Do I do that? Yeah, that works.
Okay, so I've taken.
Any questions from the oh, Esco, go ahead.
Yeah, hey, Michael, just a remark. Yeah, so the examples you mentioned, we still have the kind of older examples in, and they were not yet updated to the latest and the results of the hackathon. But I agree with you that for the document, for the not considering these examples, I think the rest is ready for the review indeed.
I kind of consider examples are updatable into Auth 48, and that's one of the things that you might do in Auth 48.
Yeah.
Is really be sure, but we can go through all the reviews. I don't think we have to wait for all of that to get the rest of the reviews happen.
Yeah, I agree.
So expect the document soon, Rob.
So you had some good suggestions for the early reviews. I was just wondering whether you want to do it publicly or not, if you have an idea about whom we should try to draft as the shepherd.
Oh, as the shepherd. I don't know who the shepherd should be.
Right, give it a thought.
Okay. No,
Really?
but other,
I would suggest you.
Yeah, that was
I don't know.
the most obvious public answer, but maybe there is a non-public answer.
otherwise, we probably should have an IoT directorate review if we haven't already. And I would really like to get the same 3 reviewers that did their major reviews for Brewski for 8995. Russ Housley reviewed it early last year and it wasn't ready yet. So I'd like to have him repeat. And the reason for that is because they've already read the other document, and therefore the diff to be constrained would be much more obvious to them. So that was Yari, Christian, and Russ that reviewed last time. So I'd love to have them do it again. I don't know if they have time. I think Christian's officially retired or something at this point in sales only. So.
Okay. Right. What's next? Where's the agenda? So, right. So we've got status update on JWS voucher. Who wants to present? Is that local or remote? Thomas, it sounds as if you want to go.
Yeah, that's me. Hello from my side. Yes. So let me take the. Where is it?
So I haven't shared the slides. Do you want to share them yourself, or do you want me to find them?
Choose a deck to share. Okay. Share. So now it should be available.
Mm-hmm.
Okay.
Yes, we see it.
So yeah, this is a short update on the JWS signed vouchers. We started some months ago, or almost a year, and it's in version 3 currently. So let's see what we have. Next slide. So here to recover a bit. This is another form factor to the original voucher RFC 8366, which specifies CMS signed JSON, and here we see another option, which is JWS signed JSON. So there are no changes to the Yang, and so this new voucher format could be used for standard Brewski, so 8995, and it also, so the Brewski PRM, so pledge in responder mode, relies on the JWS form factor here. What else do we have? Next slide. So the options we had. So initially we started with the JWS compact serialization, which you can find in chapter 3.1 of RFC 7515. And so this was an arbitrary choice, and because it was convenient, looking to the libraries, no big deal for implementations here. But lately we changed to general JWS JSON serialization for reasons. So we want to have, or maybe future use cases could require more than one signature to a voucher object, and also not to limit this new form factor to one signature, and compared to the existing vouchers like JSON and CMS, and also CBOR and cosign. So we do not want to have a difference here, because these other form factors also support multiple signatures on the voucher payload. So this is why we switched to this other form factor, and we see it, I think, on the next slide. Yes. Here I have a voucher representation. So on the left-hand side, you can see a general JWS JSON serialization syntax. Looking at the payload, it's you can see it's a voucher with some fields everybody should know. So assertion, serial number, nonce, for example, created on, pinned domain certificate. And then we see the signatures array at the bottom. So here it's only showing one signature, but the brackets indicate that you can have multiple signatures in that. So so details can be found in the draft. So figure 1 gives more details on that, and then we also have an example in the appendix, which is then the voucher itself as an example. So, and you can see it here. We have the payload base64 encoded, and then we again have the signatures array with the protected header base64 encoded, and the matching signature also base64 encoded. And that's all. So to the syntax and to the example. Yeah, history of changes. So main change was go from compact to general serialization. And what we did is also include syntax and examples for the different objects, which is pledge voucher request, registrar voucher request, and the voucher itself. That's that one. And then, yeah, the next step is to enhance the description. So I think content-wise we are complete, but we need some more writing to give some more meat in there, and to make it easy for the reader to get a good understanding of what we are doing and how the form factor is meant to be. Then we have regular alignment in the design team calls. We circulate the outcome to the mailing list, and we have POC implementations together with Brisky PRM. And yeah, also here working group review is appreciated. And I think that's it. Yeah, it's only the abbreviations. Yeah, that's it. Are there questions? No. Then we are done.
Thank you very much.
Okay, thank you.
So that brings us to Brusky PRM. Stefan?
Yep, that would be me.
Wait a second, I need to revoke the slides. And Stefan, now you can start sharing your slides.
I tried to request the slides.
Yeah, request again. That was because there was still the previous share.
Okay. So I requested. Nothing happened.
Oh, yeah. I don't know why. That should.
Okay, let me try it again. Ask to share slides.
There we go.
Ah, there it is.
Robin.
So it should be visible. Yeah, I would like to give an update of the work we are currently doing. Thanks. I would like to give an update on the work we are currently doing for Brusky and pledge in responder mode, PRM. So that's the work that besides Thomas and I, Elliot and Michael are involved in. So since the last IETF, we have two updates or two versions from the draft. So in the first update, we addressed several issues that were discussed on the Anima GitHub and in the design team. So I'm starting from the beginning. So issue 15 was we incorporated an option for additional signature of the voucher. So this is what Thomas just mentioned in the oh, those are the old slides. Yeah, anyway, we incorporated in the additional signature for the voucher, which is intended to provide a proof of possession of the registrar, proof of possession of the registrar private key. So in Brusky PRM, we reverse the roles of the pledge and the registrar in terms of pushing information down to the pledge. And at first, the registrar agent pushes down the registrar certificate to the pledge, but the pledge doesn't have a proof of possession. So we use a second a second signature of the voucher itself to provide that information down to the pledge when the voucher comes back from the MASA and is then forwarded via the pledge agent down to the registrar. So I have a slide afterwards to that as well. So then we included a new endpoint on the registrar, which became necessary because we want to deliver the wrapped enrollment request. So we have a PKCS10, which is typically provided to the EST simple enroll endpoint. In Brewski PRM, we are using a signature wrapped PKCS10. So that was the reason to define an own endpoint on the registrar to not change EST at that point in time. So then we had issue number 8 and 7. They somehow are corresponding. We were thinking in the very first beginning to support multiple CSRs during the run of Brewski PRM, but then decided to have a single CSR, certificate signing request, to enroll for an LDAF ID and entity certificate, which is a generic LDAF ID. And based on the LDAF, the generic LDAF ID, further certificates may be bootstrapped for the endpoint. So that can be done using the existing endpoints on the registrar, but it's not intended to do that on the first flight. So that was the reason to drop the support for multiple CSRs, and consequently, we also have dropped the support for additional signatures on the enrollment response, as we just have a single generic LDAF certificate as response for the enrollment request. So based on the POC, we also verified that we utilize the IETF ZTP types, the Young definition for that correctly. And issue number 4 is also solved. So that is the assertion type, which was aligned with the voucher definition in RFC 8366 bis. So we have defined a new assertion type there, which is called agent proximity. So then in the context of bootstrapping, we introduced the registrar agent that provides some information to the pledge. And one of the information here is the agent signed cert. Up to now, we had it as a single certificate, and now we changed it to an array to also address situations in which the registrar agent may have a different certificate path or a certificate path than the registrar itself. So having the array would allow to also provide intermediate certificates for the agent signed cert. So then there was some further enhancement of the text that better provides authorization checks of the registrar agent, and some further housekeeping with providing a more elaborate description of the examples that we are provided for the triggering of pledge voucher requests and enrollment requests. We also included a limitation section here to note that if the pledge is in power save mode, then there is no way in starting the communication except that the pledge comes back from the power save mode, as this is targeting the push scenario instead of the pull scenario. So then, sorry for having the old slides here. So issue number 15, I already addressed in the first version here. In the first change to version 01. So we finalized here the handling of the additional signature verification. So it's basically some enhancement of the text that was included here to have the order of the signature verification when the voucher, which is now signed also by the registrar, is received by the pledge. Then we included some further examples for the generalized JWS JSON serialization in the same way as Thomas just showed before for the JWS voucher draft, and further included error responses from the pledge if it is not able to create certain requests. So issues 7, 8, 14 are basically resolved by sticking to one certificate that is requested, the generic LDAF ID, and getting back also a single certificate. So that are all corresponding to the changes or to the issues that I've mentioned before. So just to picture this utilization of multiple signatures on the voucher response. So on the right-hand side, that is the flow chart I always used. There's an awful echo, by the way. The right-hand side shows the flow chart that I showed at the IETF before that gives some more detail on the interaction between the pledge, the registrar agent, and the domain registrar. And what we try to do here, or what we defined here, is basically the provisional accept that is used in Brewski, in the original Brewski, based on the preliminary or provisional accept and the TLS handshake. We rebuild that here by providing the certificate in the first flight and the trigger of the voucher request message from the registrar agent down to the pledge. We have the registrar included here, but in contrast to original Brewski, where you already have a proof of possession by the registrar of the corresponding private key through the TLS handshake, we don't have that here. So that was the reason to enhance the voucher, as you can see on the left-hand side, with the second signature. And that signature is provided on the way back from the MASA to the domain registrar, and the domain registrar provides that additional signature of the voucher. And then we describe the order in which to verify the signatures of this double-signed voucher to enable the pledge to, on one hand, accept the contained pinned domain certificate as new trust anchor, and also verify that the registrar with whom he is in contact really possesses the private key to the certificate that he has received in the first flight. This is just to depict that. Okay, so based on the current state of the draft, we have no open issues. So we used to collect open issues also in the draft and stated them throughout the draft. That was all of those open issues are solved. The open issues we collected on the Anima GitHub are also solved. So currently the draft itself has no open issues. What is missing right now is a more elaborate discussion in the security consideration section that needs to be updated. We have the POC implementation ongoing and also the interop testing. So that is in conjunction with what Thomas said regarding the JWS voucher. From that point of view, I would like to ask for volunteers for peer review and also request working group review.
Thank you. By the way, I think instead of just doing it here, if you reach out individual to, folks in the IETF, in the working group here or in other working groups and ask them, I think that's typically more effective. And if you can reciprocate with other documents from them or so, that typically will then even be faster.
Yep, I'll take it. Any questions to the draft?
All right, that sounds like we have a wrap on this item. So, okay, you stop the share, great. And next in line would be Brewski AE with a new member, author here. Let's see.
Can you hear me? My name is Dave.
Yeah, we can hear you fine, David. Can you try to share the slides yourself?
I would ask you to share if otherwise I can also give it a try.
I can try to share the slides and just so good with taking notes then in parallel.
Great. Thanks. Yeah, so I'm reporting on the status of Brewski AE. The current draft version is 05. And AE originally stood for asynchronous enrollment as the main use case. But since about half a year or so, in the design team, we figured that it's actually the scope can be widened, so the application scope. So the scope of technical scope is the same as before, but actually we can accommodate much more use cases, and this is much better reflected by something called an alternative enrollment protocols. And for this reason, we are also proposing to update the name of the whole draft to Brusky AE, alternative enrollment protocols in Brusky. For the same reason, we also would like to rename the repository on GitHub, so far reflecting the name async enroll, and the plan is to go to a name just saying Brusky AE, basically. Next slide, please. Just a quick recap of what Brusky AE is about. The idea is that it is a variant of standard Brusky, where instead of the usual use for when doing the certificate enrollment step, not to use EST simple enroll, but to use any other certificate enrollment protocol that supports self-contained request messages. With such type of request messages, we get independence of the transport layer and therefore have much better flexibility on where to process certificate requests. And this is reflected in this figure, focusing on the orange frame box. This is the part where after initial voucher exchange, the pledge would like to enroll a certificate. To this end, it can optionally request further certificates that it may need during the enrollment or later. It can optionally also ask for specific certificate request attributes to include in the request. And then the mandatory step is to actually request a certificate. And this is done, these three steps are done in the new protocol or whatever protocol you want to have instead of EST simple enroll. For example, you could use CMP or CMS or EST full CMC to this end. And after the request arrives at the domain registrar, still the domain registrar could do the processing or part of the processing of the enrollment request, and everything remaining can be done by a different agent, for example, an RA that is somewhere in the back end of the overall architecture. So we have some more flexibility in the system design and structure, where the RA functionality can be shared freely between the domain registrar of Brusky itself and some optional external entity doing the rest of the RA functionality. Are there any comments or questions on this, on the overall scenario?
Yeah, just Tolles here. So this, and I think the prior one as well, always makes me sad to see that these wonderful diagrams maybe just temporarily shown once in a working group meeting as what I think where they would really be great in the document. So if you folks are interested, it would really be cool if we could try to see what the current processes by which we can get at least that in the PDF. Mr. Richardson is against it. Huh? In the PDF versions of the document? Oh, that sucks. Well, but I mean, this one actually might still be very, very nice, even in grayscale, right? So grayscale it is, not black and white. So I stand with my opinion that it's a shame if that work was lost as opposed to make it into the RFCs, even in the PDF version. So if you're interested, right, ping me and we can talk with the RFC editors then if or how the tool chain works. Thank you.
Thanks a lot for this comment.
Both various opinions. Yes, this picture is very good to get the full picture what the AE is and how the procedure would be, it's very helpful. It would be a shame if we can't include that in the document. And from my understanding, a new RFC editor should already have the technology to into such picture already. We can do that.
Mm-hmm. So you mean to include it in the draft?
Yes.
Mm-hmm. Great. We'll give that a try.
But we've never tried the tool chain on how to do it, right? So let's, Mr. Rich wants to move on. All right.
Mm-hmm. By the way, I owe this picture mostly to Steffen Fries, so I just added the specifics of highlighting the AE portion of it. Yeah, then we can move on to the next slide on the current, the recent changes. Yes, since the last version, which was referenced in the last IETF, where we split the document from the Bruschi Prime. Since then, I've become the editor of the document. And as mentioned, we shifted the emphasis of the presentation, not contents-wise, but presentation-wise, towards supporting alternative enrollment protocols, and accordingly updated the title, at least provisionally. And today I would like to ask for your formal approval for this step.
Yeah, as far as the name change is concerned, whenever you have the next revision available, just change the name in the file name, put in what the prior name is, so it's just during the data tracker upload. Then if I'm not mistaken, it'll ask for working group chair approval, and then we're done with it.
Mm-hmm. Thanks.
Is that Carsten has something to say?
Pardon?
Oh no, I saw Carsten raise his hand. Go ahead.
All right. Mm-hmm. Yeah. Apart from this major shift of focus of the text, we moved around some sections towards appendix in order to make the document more readable, and also shuffle around some other sections, and also streamline the wording, and we consolidated the terminology, and etc. So meanwhile, I would say the document is in the pretty stable status already, where it should be pretty convenient to read. And therefore, yeah, I think it's a good opportunity also to ask any of you who is interested to have a look at it and do an informal review, and we're would be very glad to receive further comments on it. Next slide, please. Yes. What is going to be done next? While internally reviewing the text, we noticed that we have two parts that need some little further work of getting more details in, which is describing in more detail the instantiation of this framework to using the Lightweight CMP profile, so using the CMP protocol. And there it turns out that we should give some more detail how to transfer further certificates during the enrollment process, whether to use the search request template, message flow, or rely on the domain registrar to do any further completion of the certificate request. We should also clarify whether we want to stick with doing a certificate confirmation within CMP in a classical way, or use the implicit confirm. While I should have noticed, anyway, in Bruschi, in the outer protocol, there will be an enrollment status confirmation message at the end of the general Bruschi message exchange. We also need to make up our minds whether we should specify the use of PKCS10 format within CMP, which could be useful for legacy support. Apart from the CMP instantiation, the plan was also to have an EST with full CMC instantiation of BRUSCKY AE. This should be provided by Elliot, but unfortunately he hasn't had time apparently to work on this. So we would need to see how, if we can get some more details on this, or can just leave the EST section as it is, which in a not very detailed fashion. I plan to do a next version of the draft document when these two items have been completed. And as mentioned, would be very nice to get some reviews and comments. And we are also doing POC implementation currently. And if anyone is interested to do an interoperability testing, please let us know. Yeah, that's basically all I would like to share with you. Are there comments or questions? Apparently not. Thank you.
Thank you very much. Michael, you want to step up to the mic again? Yeah, it's 8366 if I find the slides and the Richardson line.
And
Michael,
I noticed that if you let your phone,
Michael,
you have it on
before
your
you
phone.
start, I have
Yes.
a question. Sorry, I should ask this earlier. What happened to your working group draft virtual delegation?
It hasn't been updated. That's what happened.
Okay, so you are not give up it yet, right?
No. It's just the relevance is. We could talk about this later, okay? And when we at the end of the open time, okay? If that's okay.
Okay. Yeah, that's fine because I just noticed that missed already expired last December. Right. Okay, go ahead. Sorry for interrupting.
Okay, so I'm going to talk about 8366 bis, which we adopted. What was it? December, I guess, in the end. Maybe it was January. What was the initial motivation for this is that, particularly coming from the alternate enrollment, was that we realized that we wanted to extend this Yang enumerated type called assertion. That's not possible to do that without revising the Yang module. And so this was motivated by this. And of course, we wouldn't like to repeat the effort again. So what do? We basically, the solution is that we take this particular item, we put it in a submodule, and which we import, and then we arrange for IANA to manage this module, and we create a registry around it. And essentially what happens is that whenever someone comes along and follows the IANA considerations to allocate this value, then the IANA will in fact turn around and essentially edit the Yang module and create a new Yang module, a new entry, a new revision there with the new stuff there. So effectively what we've done is we've turned the IANA people into Yang editing robots, which we can remote control, and hopefully they won't, take over the world or something like that. So my belief is that this has no effect on any bits on the wire, that everything looks the same at the end of the day. And if, you know, someone was actually generating code from Yang modules, this would be useful because then they would have the most up-to-date things. So what do? We turned it all into Markdown. Since the RFC 8366 was first worked on, it was in a Git repository, but that was long before Martin Thompson's makefile existed, so we've added that. A bunch of rules to process the Yang file in the makefile, and to do all the right things, and the working group adopted the document finally. So what's next? So first of all, we used, what's it called? The one before SX structure, Yang data model, and that's apparently not sexy anymore. So, pardon me? Oh, I thought someone said that. That's not sexy anymore. Now we should be using RFC 8791, which is this SX structure stuff. I don't really understand the difference between the two. I think that it's just a different way, a Yang way of expressing things, and I think that it will result also in no wire changes. Just we would now be expressing our Yang module in the modern 2020 onwards way. I would like someone else to, you know, follow breadcrumbs through and figure that out. That would be a really good review to do if you know Yang, and particularly if you're an expert in 8791. So that's a change of the text. Secondly, we need to go through 8366 and see if there were optional things that we spoke about, we wrote about, that either need clarification at this point, or were just dumb ideas and we should just remove them, okay? The goal of this is, could we publish as internet standard at the end of the day, okay, as opposed to proposed standard? And that's a question for our AD, Rob, over there. He's not really paying attention to us. It's probably Friday afternoon. Anyway, could we publish 8366 bits as proposed internet standard, given that we are re-expressing it in a, you know, several different versions of more modern versions of Yang, but not, I think, changing any bits on the wire or invalidating any interoperability testing that we now actually have a fair bit about effort, not just in Anima, but also over in the netmod ZeroConf space.
So on that specific question, I was paying attention. On that specific question, I think going to PS first for this document would be better. I think going directly to internet standard might be questionable in terms of how much stuff is changing. I can have a look, but I think it's a question of whether the changes are significant or not. So I think I need to review that carefully, but I could get back to you on that.
Right. So just to restate it, we're really changing the Yang, the expression of the content, but not any of the content itself. Yeah. So it could be that we introduce, I agree with you, it could be that we introduce unintended bugs in the Yang in how we express it, but I think that's relatively unlikely. But what you're suggesting is that we publish as PS and that a later ISG could redesignate it, you know, if we think we're okay. That would be the safer way.
That would be the safer, easier way.
Yeah.
I said Kent was thank you.
Oh, yeah, Kent, hey. As he finds the unmute button.
Can you hear me?
We can now.
Okay, wonderful. The difference between Yang data and SS structure. Yang data does not define a protocol accessible node. The simplest way to make an analogy is Yang data is like a grouping, whereas SS structure is like a container.
Okay. Okay, and will it change any of the content in the end? The serialized JSON, for instance?
All the inner nodes, of course, are rendered the same. It's
Yes.
just the outermost envelope container, or that outermost node doesn't exist in Yang data, but it does exist in SS structure. So wherever Yang data was instantiated before, it was probably wrapped by some sort of container or envelope, and the name of that envelope now needs to be the name of the SS structure, and then you'll have the equivalent.
Okay, so if we can accomplish that, then we will accomplish no bits in the wire change then.
Yep.
Yeah. And what do you think about going to internet standard? Do you think that the experience on over in net comp is mature enough to justify that?
Well, I don't want to swim outside my lane, but I've never heard of a draft like this to going to internet standards so quickly. So
okay, all right. So you think we should do it PS, and maybe we'll get it blessed later on.
Yeah, I think the interesting question will be what the IETF thinks about the standard level, not with respect to how stuff works interoperable on the wire, but also interoperable on the tooling side, right? Because you're just using a completely, because I guess that new stuff, you don't even have the tool chains, which is why you want to have some more manual review as opposed to simply checking it in the tool chain.
Well, we don't have code generators that are going to actually process it, but we do we do know how the serialization works and all that other stuff. So that's I think okay. So I have a second question, or the third question actually. So one of the things that we are doing in so JWS voucher is one of the unique documents that doesn't extend 8366 at all. Constrained voucher extends it. There's another document that extends it. Now I can't remember what it is. There's 2 or 3 documents that have taken 8366 and extended it, often in orthogonal directions, and you should actually be able to combine the extensions at the same time. I don't know how to express that. So the question is, those documents now, they're still extending 8366, and the question is, well, should an 8366 BIS, should it go and now reach in and take those extensions and include it into the 8366 BIS document as, additional sections or something like that to make it a little more, inclusive, or should it just continue on and do what it does and be only what it is and have extensions that happen there? And the extensions happen with the grouping that we created. I don't know the answer to that question. And in particular, I don't know how to tell someone to use 8366 plus whatever constrained voucher comes up with, plus say whatever delegated voucher comes up with, because those are orthogonal extensions. You should be able to combine them. But I'm going to tell you, here's 3 RFCs to implement. And I don't know how to mix that yang. If I was doing a code generator, I wouldn't know how to put that yang together. I don't know if that matters. I don't know if it even, it may be just perfectly fine for someone to say, here's 3 RFCs, mix them all together, you won't have any problem, and that's it.
I think process-wise will stay. I mean, the smart money is on keeping it separate. If I were thinking about, trying to write a document that has all the IPv6 extension headers together, and then, things were retired later on, what you do, right? So that would affect everything together. So by keeping things in separate documents, it also means that we can change their status accordingly over time.
Absolutely. So that's the point. So I was trying to get the status, but then there's also the technical side. But you know what? We do sometimes come along like DHCP v6 BIS, right? 8415. We actually pulled all the extensions into one document, and it made sense to do that at the time, right? And I'm just sort of asking, well, does that make any sense?
Rob Wilton, is Kent still in the queue? I don't know, but I'll jump in anyway. Just one observation: you've also got the wonderful updates tag that is very vaguely defined. So you could also update the other 2 extensions if there's anything required to explain how they worked with the updated version of 8366 BIS.
8366 BIS could update these other extensions.
Yeah, just
yes,
the
okay.
documents, just to sort of flag them.
Okay, that's a good point. And I think the timing will be such that they'll actually be published beforehand anyway, or maybe at the same time, but anyway. Okay, thank you. That's all I have. Anyone else have any questions? Some people, you guys are still in the queue. Kent, did you have another thing to say?
Yes, regarding pulling things into 8366, another consideration is that I would imagine the BIS would obsolete the 8366.
Right.
That's the typical thing that's done. Yet we have 8572 SCPP, which depends on 8366 and would not be able to incorporate whatever orthogonal extensions you're referring to.
Yeah.
So that could cause problems for 8572 if that were to happen.
If it were to be obsoleted?
Yes. Well, if suddenly there was a new RFC that replaced 83C6 and included these orthogonal extensions that 8572 could not take advantage of, then implementations of 8572 might be left in a situation that'd be difficult for them.
So not including extensions would make it easier for other things that are depending on it. I hear what you're saying. I agree with you completely. So that completely you know, settles for me any decision about whether we would incorporate anything else.
I mean, maybe it's also status check, right? I don't think we've always obsoleted the prior version. Is TLS 1.2 obsolete?
I think that's a separate, different kind of conversation.
Right.
I think you should ask, is RFC 822 obsolete? It's been replaced twice.
Right, but if we don't obsolete 8366, but we just, you know, supersede it, it's kind of maybe less of a problem for the existing documents like 8572. Just, you know, playing correctly with the status.
No, I think it's okay if we obsolete it because the new document has the same content. And so it's perfectly fine for the other documents to just say, oh, well, we're just moving up to the new one, and that's fine. I think that's as long as the content is the same, right? And that's what Kent's point was. Otherwise, you'd have to say new document minus this other stuff, right? And then that's, I think, too complicated. Carsten?
Well, to answer the question, TLS 1.3 does obsolete TLS 1.2.
Thank you.
2. All right. Thanks for looking. Anybody else? I wheeled my
I'm trying
remote
to get
clicker.
you the next slide deck, but I'm not sure what you're doing there. Oh, there's Brusky Cloud coming up next. I guess so, unless you want to designate somebody else.
Oh, all right. Well, I did look at the slides just earlier because I thought it was you that was going to be doing them. I think we did publish a new version since the last version.
03.
So just to remind you, there's a section in Brusky that says that devices may want to talk to the cloud directly instead of talking to a local registrar, and is intentionally does not specify that, and this document does. So we started with a bunch of different use cases, I think 4 of them. We got rid of a couple of them, and essentially there's 2 use cases. One is that there's no local mechanism to find the registrar, such as perhaps you are deploying a device, such as maybe a SIP phone at someone's home, but it needs to talk to the registrar, which is at the office headquarters. And the cloud could redirect it, and it's literally done with an HTTP redirect, and we had a conversation about which one, and the document says that. And then that was the first one, so there's your 307 thing. And then the other case is that the registrar does not speak Brusky, but does speak EST, in which case the cloud will return a voucher that points it directly to the correct and pins the correct registrar. That's just one of the places where we have an extension to 8366. Now I remember that's orthogonal. So that's a separate use case. In that case, the cloud acts as a partial registrar, but it pins this other device, and then you go to that place and just do EST with that. So the document explains that part as well. We went through security considerations before the last IETF, and I think they were reasonably well accepted, but we're really ready for working group last call and, reviews, sector review would be great. And maybe even some review from HTTP people or something like that. They could tell us if we got 307 right. I think that's it. Yeah, that's the last slide. Any questions? No? Okay.
Great. Thank you. Right, so I think like we did with the last document, you probably have the best starting suggestion for the sector review, so work with me. I'll get those. No, last time you had some good suggestion who the favorite reviewers would be, so please provide me the input so that we get the best possible review done. Okay. Eugene, you're next with the autonomic mechanism for resource-based network services auto deployment.
Can you hear me?
Yep.
Is my share my screen?
Yep. You're a little bit loud, so if you tone down your level a little bit, I think that would be good.
Sorry, wait. Okay. Sorry. It's okay now?
Yeah, it's still on the high end level, but we'll survive.
Can you hear me clearly?
It's just very loud. So maybe if you can, I'm not sure what type of microphone you have. Just a little bit further away, maybe.
Oh, sorry.
No worries.
Okay. Let's start. And this talk is about an auto deployment mechanism for resource-based network. Okay. At first, I will have a review about our draft, and the core goal of this draft is want to establish a set of autonomic negotiation mechanism to achieve the negotiation and the distribution of the network resource in the domain network. And that means ASA will negotiation with the service plan and decide how much resource the service can use in the domain network. And we think the draft can slow the target of the draft. The first is we want to the resource-based networks can get the resource autonomy and satisfy the truth requirements of the service. And the next second is the mechanism of the supporting multiple rounds of the negotiation that enables the service client to change the resource requirement according to the state of the network. For example, if the network is congested and the service can reduce the quality of the resource. And the third, the mechanism can ensure that the resource in the domain network can be used more efficiently. We think that a smart network should provide different levels of network resource for different level of the service. And this is our goal of the draft. And this is a major change from the 112 sessions. And in this slope, I want to discuss an example with parameters. And we think this may make our draft more easy to become realized. And this page is about the auto deployment process, and we include 3 process: discovery stage, and negotiation, and something the ASA will do after negotiation and in the discovery part and within the resource manager ASAs in the discovery method to find the providing resource manager ASA, and when the request resource manager ASA want to get resource, they will send a message to providing resource manager ASA. And in the negotiation part stage, and this mechanism allowed multiple rounds of negotiation, and the two ASA will decide the how much resource the service get, and the requesting resource manager ASA will decide at each round how much the resource need to offer, and the providing resource manager will respond how large the resource they can offer, and that means the providing resource manager ASA will consider the network state and the server's information and decide how much resource can offer. And after negotiation, the two ASA get the result, and the providing resource manager ASA will remove the accessible resource from the resource pool. And we should emphasize that this draft is about negotiation how much resource as resource can offer to the servers, and it not release resource whole by whole. This is the objective, grasp objective we define in the draft, and I think the most important thing is about the objective value. And nowadays we think they are include two parts. So one is about service information, and another is about the resource information. So the service information, we think the ASA can use this to communicate who asks the resource and the service level. And as for the resource information, is about how much resource they should offer. And I think this objective is not in JSON, and I think this is easy to understand. But I think this objective maybe need to be discussed more, and I think I will start a mail to discuss this question, and I think this is important thing we will do the next step. This is an example about how to use this negotiate grasp objective, and we added some parameters. And in this page, we see that the server initial play a role of request resource manager ASA, and she will ask resource to the providing resource ASA, and this is negotiation message. And at the first round, the SI will ask the 10 megabits per second and bandwidth. So they ask 10, and the 0 means bandwidth, and 10 is a value. But I think, as for the providing resource manager ASA, it receives a message, and if the network is not very busy, it will respond accept. But if the network is the resource is shortage, she will, like the page says, she will respond 8, and the next round is request resource manager ASA, and she will decide the 8 if the 8 is enough. And I think see the pictures, it says 8 megabits is enough, so she will send the message and the providing resource manager will accept. And this is the example of negotiation process. And this is a new step we add in the draft, and it's about how if the example of the changing resource requirement, and more detail we can see in the draft. And for next step, we will have a more discuss about our draft, and hope other people can help us and become a co-author. Thank you.
Any questions here? I don't see anybody online. So yeah, I'll review the document and provide feedback on the list. I think it would be great to, so the slides already show a little bit more details on the example use case here than the draft itself. That's great. I think would be good to bring this down to a fully explicit example use case. And I'm not sure what type of proof of concept code you have, but I think such a proof of concept code that would actually result in the reservation of a resource would help a lot. So for example, you're showing the step-by-step process to talk with the nodes along the path, but how do you know the path for a particular service instance that you want to do? I think that's not being answered. And then of course, picking some way to, I guess, actually guarantee the bandwidth, that should also be given as an example. And yeah, I guess that the example you're showing would be some form of alternative to something that in the past RSVP has done. And I guess that discussion of how this mechanism would be better in comparison to such prior examples, that would also help to distinguish the proposal.
Okay, thank you.
To the list. Sure.
Anyone have a question?
Okay.
Okay.
And I think you're up again for the next slot.
Yes, the next.
Mapping.
Yes,
so
the next.
Yeah. So now this is the first draft here that we're discussing that is not working group adopted, but individual draft so far.
Yeah. Okay, I will start about this draft. And this draft is about autonomic IP address to access control group mapping. And at first, I will reveal the basic idea of the draft. And this is a picture of an example of campus network. And in this network, it includes access node and ASA we defined in the draft. And here, the AAP represents the access authentication point ASA, and PP represents the ASA of police's enforcement point. And this draft want to solve the question about how to autonomously configure the policy for user in the network. And we use the group-based policy to deal with it. And in our draft, the group means a number of endpoints connecting to the network that share common network policy. For example, if one user accepts the network, and if they change the access point, they maybe get the different IP. But we think that the user want to get the same network service, so that our draft want to solve this program. And this is our change from the last version. And in our slide, we will give the example about how this mechanism work, and I think this will make others know more about our draft. This page will show the grasp we define in the draft, and it includes AAP objective and the PEP objective, and this is our defined. And this page is about an example about how AAP gets IP address and group ID mapping information for a house, for a host, and we think it is prior knowledge for Anima objective, and we must emphasize that this is only just an example, and it is not be a standard. There are many ways can let the AAP get this mapping information, and this is our example. And in the example, the host A joins the network, and AAP use travel A server to get the map to group ID mapping information. First, as the figure shows that host A access the network, and its access node is AAP, and host A will send its MAC address to the domain network in order to get authentication and some other information. So the AAP uses MAC address to request group ID to AAA server, and the AAA server will reply the request with MAC A is okay, and the group ID is 5. So the AAP will store this information in their local memory. And for next step, after passing the authentication, the host A can use the DHCP process to get their IP address, and so that the AAP can get the mapping information about IPA to MAC A, and eventually the AAP uses these two information and get the MAP A is to group 5. So this is an example about how AAP gets the group ID information. And this is this page is about how the AAP pushing map information to PEPs, and we also include the discovery stage and the negotiation stage. And as this picture show, and first the AAP will send a discovery message to PEP and get the PEP node, and after that the AAP will send a request negotiation message to the negotiation message include IPA and group ID 5 to the PEP, and the PEP will save this information, and they will use this mapping table to enforce the policy. And if the PEP receives this message, they will start the mapping table in their local memory, and will respond to the negotiation and the message. This is this picture is about how the PEP uses IP to group information to enforce the policy. And as an example, a user whose IP address is IPA want to send a package to the database machine whose IP address is IPB, like the orange line in the picture. We say that the IPA is group 5 and the IPB is group 10. But we know that the policy says that IP5 to group IP5 to group IP10 is dropped and is forbidden. So the PEP will will do something to enforce the policy. And in this mechanism, the PEP will get the data package and find the source IP, IPA, and to the target IP is IPB, and then they use their information, sorted information, and get the IPB A is the group 5, and the IPB is the group 10, and it also finds the policy 510 drop. That means the pipe should drop the package. So the PEP will drop the package and enforce policy. And this is how the PEP enforce policy. And if the IPA changes this access point and get the new IP address is IPC, but we know that the IPC is also in the group file, so the PEP also can find that IPC to IPB is also forbidden, so it will also drop the package. And this is how the PEP uses information to manage the network. And this is all about our draft. And the author think this draft is being relatively complete. So we want to think this draft is ready for call adoption. Thank you.
Any questions?
Tom Hong, go ahead.
From China Mobile. I'm happy to see that this draft. We have seen that the growing demand and deployment for group-based policy in the network. This idea is very attractive feature for Anima ASA, and in my opinion, perhaps this can work for the security scenario. Is that a use case for that?
Use case for what? Scenario?
Security.
Security. Sorry.
Some IP is not allowed to access some node, and in this mechanism, they can control this access. In my opinion.
Yes, I know this question. This question I think we will add in the future if the IP is not found.
Okay, thank you.
Go ahead, Ida.
Actually, I answer a little bit more regarding Zhongpeng's question about the security. So, speaking as one of the co-authors, yeah, I think in broad scope we can say that it is also for security purpose. But I guess most likely we'll consider is like for the policy enforcement. So it depending on how you categorize this. So in broad scope, yeah, it is security. In narrow scope, it is more considered as the policy side. That's what I'm trying to say. Thank you.
Yeah, I do have some questions, clarification questions. Could you go back to slides?
This page or
this? Yeah, here. I know that page. Yeah, here I get confused by this example because in this figure you actually only show the procedure between the host and the AAA server and between the host and the DHCP server, which we can reuse the existing authentication protocols or the existing DHC protocols. If that's the case, so why Anima? Yeah. Yeah. My next question is similar. Could you go next page? Yeah. Here, you give an example of negotiation, but from the procedure you have on this figure, it's the normal request and response model. Where is the negotiation? I cannot say how negotiation happens. You request something with certain group ID and receive something or some allocation information back. Then that's a request and a response. It seems misused for negotiation.
Yes, I know what you say.
Ido, go ahead.
Yeah. Yeah, that's a good question. So maybe we can take a look at the previous page first. Yeah, that's regarding. So as Yujing just now showed, this is just an example. So basically, if the whole system deployed the Anima, we are thinking that would be one of the essential component for the whole Anima deployment. Here, this is just to show the readers that even some part is not animalized. This can be standalone piece for the work, which can be a standalone piece for the Anima ASA. So that's also why the reason Yujing put here as this is not going to be standardized. So just to show there are different possibility how to use it. So that's
okay. That's fine. But
yeah.
I would like to say another update example which shows, what would be unified, Unicode value for use the Anima or GRASP protocols, right?
Yeah, that's valid. I think we can add a description or paragraph to the existing document to have an introduction on this what you suggested.
Okay.
And yeah, for the next one, yeah, you're right. We are using the negotiation, so it can be treated as a single request and reply mode of the negotiation. So basically, of course, this is basically like the PEP point received this negotiation request. Of course, here our assumption is PEP just approve such negotiation, this mapping unconditionally. But in the real deployment, of course, because the PEP is a policy enforcement point, it can use some predefined policy. It can reject this negotiation. So it's still quite a common sense for the Anima defined request and negotiation and the negotiation and the policy. But here for the illustration purpose, we just assume everything is okay. So the PEP accept this. So hope this reply your question.
Yes and no. Yes, you explain why you use this figure or this example, but that's much better if you can, show a better example which express how the negotiation may happen. That would be better.
Yeah. So because this one actually was added to the latest version, which also suggested by Tollers and I think by Brian, because the original version was too abstract. Currently, we are using this flowchart to give a more solid example. So I think one of the way to deal with it, we can try to add something, say that if there is if the PEP doesn't allow this, then actually the negotiation negotiation and message, it's not 100% accept case. It can be something like the deny. So we add this example to show that it is there are different consequences, there are different results for negotiation. I think that's yeah.
So maybe from my side a comment. So what this seems to be in the direction of is something similar to what we've been doing for maybe now 30 years, AAA, between policy decision point and policy enforcement points with protocols like TACAX, radius, diameter. And so that comparison, right, in terms of what can those solutions not do that we can do with the with this Anima approach, I think would be helpful. But that, of course, is a lot of work trying to figure out what you can actually do with what we have been built up over 30 years with, radius, diameter, TACAX. So that's not free to wrap up to. But I think the problem is that if you don't do it, at some point in time, the people who do know those technologies will come for review and say, well, we can do everything that you're trying to do new here already with the old stuff. Maybe it's a little bit more crappy, which certainly everybody agrees to is most of the stuff that's 30 years old. But as long as it can be done, the desire to do something new is very often much reduced. So that's, I think, one of the challenges. And I think what is helpful with understanding that old stuff is trying to find the most easy places where the old stuff cannot do it, right? So for example, what you're showing here, where you're pushing stuff out to multiple points, that is getting in the direction where the typical AAA solutions do not work well, because they're typically really based on request reply, based on a new device showing up at some place. That's where the request reply for the authentication authorization is triggered. Yeah, let's not carry on too long. We can take it to the list, but that was the general idea. Thanks.
Yeah, thanks.
Any more questions? Okay. So I think it's me then. Let me bring up the slides. All right, last slot. This is about 2 drafts that I had presented a couple of times in the past already, and then never found the time to prioritize them on my own top of the line due to the other Anima work. So I wanted to get back to that with a couple of the co-authors we now have on these 2 documents, and revive this, and also then ask for working group adoption. The documents are quite stable from the content and functionality that we're asking for, obviously not from the text quality, details, and ease of read. So please read the documents, but hopefully the refresher here will also help to get the gist of what it's about. So we've got the autonomic networks that we want, right? Brewski is autonomic, we hope, zero touch, except, power and Ethernet cables maybe. But what if anything goes wrong? How about the troubleshooting side, right? And how about the ACP then, which supposedly is booted automatically after Brewski? So the first and most simple use case I would like to finish up is really to get something that we described in RFC 8366, which is the ACP for the autonomous network that is controlled in a traditional form from an operator centrally or with or without SDN controller to get that working reliably with Brewski and ACP. And with the experience from the pre-standard ACP implementations that I worked on, we really need a few infrastructure services for this to run, to successfully bring up Brewski and the ACP for troubleshooting, and then of course also to securely access devices across the ACP from the NOC by an operator through the CLI or an SDN controller. So that's kind of was the starting point for what I wanted to achieve, which is kind of still the most important use case, but as we'll see, what we're proposing to standardize will support a lot more. So the core ANI infrastructure services, right? So the most important stuff from the operational experience with pre-standard is really syslog that automatically runs and can, signal, any type of thing that, for example, happens from the Brewski proxy back to the registrar or a syslog server in some other place so that we actually know when something goes wrong, but equally when something is working, that the registrar, for example, uses syslog to notify when a new device is being enrolled, and that then the next steps can be taken in some automated workflow. So syslog is the first service, right, that all the ACP nodes can start syslogging what they're doing in the ANI infrastructure, Brewski proxy and whatever else the components are. Clock synchronization to some selected NTP service across the ACP. We need good times even just for basic crypto and certificate validation. We did a lot of jumping around hoops to try to minimize dependency against clocking in Brewski, but of course life is a lot easier if you do have good synchronized time, even if it's just, tracing of event propagation, just, this message came here, that message came there, oh, they were 5 milliseconds apart, which was first, which was second. Very easy to do if you have NTP, otherwise you're kind of very much lost. And then the remote access to the nodes via the ACP, that would really be SSH through the ACP, but these days it's really very convoluted and not good enough just to rely on SSH authentication through the ACP certificates. So it's a lot easier if you have the standard authentication and authorization of access into SSH for controllers, for operators, when you can rely on the standard authorization and authentication tool chain through radius, TACAX, or diameter, radius being the foremost standard of the IETF in that space. So you need to be able to discover in the ACP your radio server across the ACP, and then simply whenever somebody logs in through SSH, whether it's a controller using netconf across SSH or an operator using CLI, that the standard authentication and authorization in terms of here are the commands that can be done, that all that existing stuff is simply automated across the ACP, including that radius authentication. And then, of course, there is the alternative that we got from netconf recently, Ken's work in the working group, the call home, where you discover a netconf server and you're after you're being enrolled by Brewski and have an ACP, you would discover, hey, there's a netconf call home server. Let me connect to that so that the rest of the configuration happens through netconf, for example. Finally, what I think among the, these core ANI infrastructure services would be to auto-enable DNS across the ACP. Simply just, the poor operator using the CLI could then much easier get rid of having to look at IPv6 addresses by simply, also having DNS set up that it has good DNS names for all the operational IPv6 addresses, because so far the operators are really, well, I can't remember these long addresses at least. All right, and that brings us really to the draft Anima services DNS autoconfig, which really is just trying to achieve exactly what the prior slide said, right? So the operator sets up servers in the NOC. Those servers need to support IPv6, syslog, NTP, DNS, radius, diameter, netconf, whatever subset of those the operator feels he wants to have automated running in the ANI. Connects those servers to the ANI typically through an ACP Connect interface to the NOC. That's specified in the ACP RFC. Of course, nothing yet happens. Then the operator enables the service announcements for the ACP, right? So those could simply be automatically by the servers themselves using DNS SD over MDNS, or the service announcements are a feature on that edge router, the ACP Connect, when those existing servers don't support DNS SD, right? So now all the ACP nodes start getting through the ACP the service announcements, and they automatically start their local agents, the NTP agent, DNS, radius, so basically the ASAs for exactly those infrastructure services. And yeah, as I said, from the operational experience, that is most important really after you're connecting and enrolling new devices into the ANI. And again, nothing of this will run unless the operator explicitly, in the NOC enables it, right? So that there's no additional magic that happens without the, intent of the operator. And that is then very easily done on the servers or on the edge router. So now how do we announce those services across the ACP? Well, we have and we want to use GRASP across the ACP, but we do not want to reinvent the wheel when there already is a wheel. And that wheel exists, and that is really, the service definitions that we have in DNS SD. That has pretty much most of what we need. It has the services name with the wonderful IANA registries, and then a bunch of interesting parameters, service instance names, priority, weight, text parameters. None of this is actually specific to DNS. DNS is just the transport. And yeah, I just got some information on going to add about the history of this. This actually originated way before IP in Apple's local talk as service discovery and binding. So in the same way, we're just trying to decouple this now from the DNS binding so that we can use it across GRASP, where actually it will hopefully become a lot easier. And this is here actually how it would look like in GRASP. So this is the draft Eckert Anima GRASP DNS SD. In DNS, the data for a single service instance is split across 4 or more resource records. So the quad A's to get the address resolution, the CNAME pointer. Stuart, go ahead.
I just want to briefly say I support this direction. Your summary is exactly right. The key concept here is the IANA registry, RFC 6335, I think, if that's right by memory. And you're absolutely right. The encoding of that into DNS records is useful in certain contexts. I can give you examples of other contexts that are not widely used outside of Apple, but they are examples of what's been done over Bluetooth. The same namespace of service types is used to describe IP services, but over Bluetooth discovery frames, which are not DNS formatted. And it's also used in peer-to-peer Wi-Fi, again, encoded, and I don't know the details, but some kind of Wi-Fi public action frame that's also not using DNS format messages. So we do have a precedent. The key thing is not to invent a new registry of service types. That would be really reinventing the wheel for no reason.
Yeah. Not only the service types, but also the parameters that we have, right? Priority, weight, so that the whole management of, you have multiple service instances, how you think about redundancy, selection, that is as consistent as we can get it. So the only thing that I figured out we can add in the case of GRASP is that we have a notion of distance to the server because we hop by hop forward it, which we kind of always fail to do correctly in multi-hop MDNS. That's been the pain. But so we've got the distance as one added, criteria we can use, which may not be applicable to all environments, but which would then only be for the ACP case. Right. So in DNS, it's split up across a bunch of different resource records. And that also means you have multiple back and forth hops you need to go through before you have all the information if you haven't cached it in before. And in GRASP, it's really very simple because we can, just for the announcement of flooding service information, put everything into a single grasp objective, and that's what I've shown you on the right-hand side. And if you look at the words here, you'll find all the same things that you'll find scattered around the MDNS solution, like the instance, the service priority weight, and then the additional extensive text things, KV pairs. So that's all being mapped, and then only the distance would be a new one that we can't really map back to MDNS. So then the key part of reusing the service registry. So for the objective names, we have our own registry. So what I'm proposing here is a little bit of a hacky thing, which is that if an objective has a grasp name of serve.name, then the name after that has to be a name that was registered exactly in that existing DNS-SD service registry, right? And that basically then gives us exactly the fact that when you're using such a name, you must use this encoding format to announce it in grasp so that it stays in its definition also compatible with DNS-SD as far as all the behavior and the parameters are concerned.
Hold on a second. Michael, do you have a question? You raise your hand. Michael Richardson.
It's not really a clarifying question. Michael Richardson at the mic. I did like, Carlos, that you talked about DNS over the ACP and names. And since we're using an ULA, the reverse map, the only way to get the answers from the reverse map is to use the local recursive DNS server, because if you use a public one, of course, you won't get anything useful. And so that's really important as to in your, you know, in your syslogs, when you're receiving them from other things, you'd like to put the name of the actual machine, not its current, you know, the IP address it currently happened to use to talk to you. So we actually need to think maybe whether or not we want to do reverse map updates using DNS update, using some SIG0 type key, which of course we would have to discover with GRASP to find out which server to update to, or whether or not we want to actually do reverse map updates using GRASP.
Yeah.
Okay, so that might be an interesting ASA that we might just find. That might be, it might be easier. Most people have a lot of difficulty getting DNS updates to work outside of Microsoft Active Directory. And there's some subtle cryptographic reasons why it's hard and needs to be that way. But we should probably think about whether or not what we want to do and have an opinion on it. It seems like a good service that the ACP ought to do, which is forward and reverse naming for the ACP things.
Yeah.
In particular, when you reach out and want to SSH to some enterprise equipment across the planet, it might be actually useful if we had a opinion, we are opinionated as about how you named that piece of equipment, such that you want to go through the ACP versus you name it such that, you know, you'll just go over your public network, because there's reasons to do both. And sometimes you actually want to check if the public network is working, and sometimes you actually want to check if actually the machine is up and going through the ACP is a better choice, because that is more likely to be working. So that's actually the other side of the thing. On the naming side, we may actually want to have some opinions that say, you know, this is a really good way to do it. Maybe this is, you won't want to do it everywhere, but at least we would then be creating a, you know, a convention about that. And we could argue a lot about the details, but I think that would be really useful to do that. I think that's something that this document could do.
I fully agree with the intention. I think you brought it up already once. So I don't think it belongs into either of these two documents. I think it would be a separate document, just because this is really just services.
Well, no, but some of the new services that we actually might want to say that need to exist is this kind of stuff, and then we would have to point to something else that actually implemented them, is what I'm trying to say. Meaning it's like, don't bring up an ACP and not turn on these services. That would be silly, right?
But I think you're going one step further, right? So, I mean, I'm just trying to discover the services there, and yeah, I'll have to think more about what I think is the good logical separation line between
different pieces of work so that each of them can best be reused without creating unnecessary dependencies. Yeah, thank you. All right, so how do we operationalize the whole thing? So ideally, if we think about, we write ASAs or whatever it is, we introduce an application API through which service announcement and discoveries can be made. Thinking about whether we can have just a very simple, announce, discover, abstract API specification in the draft. And then the API library can actually select whether to use GRASP or DNS as an implementation choice, maybe by automatically discovering the context. Well, I do have an ACP, let me use GRASP, otherwise let me use DNS. On the ACP router, it's easy to announce a simple, to configure a simple announcer for the services if you do have legacy existing services that can't do DNS SD. Otherwise, it would be a GRASP DNS SD to MDNS gateway. Brian Carpenter had already played around a little bit and started to do that. I'm not sure how far he had gotten on the MDNS side there. And then, as I started to allude to earlier, this objective format with all these parameters in its standardized fashion must be used when you use the serve.name, and you must then use that as a registered name in the services registry. And this must be used when you want to have a service not only visible in GRASP, but where you want it possibly across a different type of transports. So I think Brian gave a good counterexample. Brian gave an example of an objective that was just meant to give service parameters that are specifically to GRASP itself. For those type of things, it wouldn't be necessary or beneficial to use a serve.name thing because it's specific to the GRASP protocol. All right, so summary proposal is for the two drafts, which are serving very much combined goals, but independent of each other. The first one is the encoding in GRASP of service specification that are compatible with the DNS SD service specifications, including that definition of the binding between the GRASP objective registry and the service registry by coming up with this serve.name. And the second one being the services DNS autoconfig, which is really ultimately a specification of a few basic ASAs for the ANI itself to operate autonomously, come up to the point where you can remotely manage it from an SDN controller. So it's an ASA to start syslog, NTP, SSHD, netconf call home, DNS resolver, and radius authentication client, right? So a bunch of the most core ASA we can think of, and that is using for its own auto configuration those DNS SD compatible GRASP service discoveries. So that's it, really. Really would like to see adoption call for these two drafts to the working group. And yeah, please read the drafts, comment on them, and then chime in when we have such an adoption call.
Hi, Terence.
We're 2 minutes over. That is a big no-no here in the IETF. We're so sorry.
You must allow me to say something because I would be the chair to launch the adoption call if needed. Yeah. Without my Anima chair hat, I support this work. That's very useful work, and I think that would benefit the atomic network in total. But put my working group chair hat on, I have two small concerns here. One is, apart from the presentation you're giving in the meetings, I would like to see more discussing in mailing list, right? You maybe ask somebody to review the two draft and publish his comments in the mailing list, right? Second, I'm slightly worried you are overloaded a lot. You should probably do some document shepherd first. Joking. Yeah, but I would like you to get guarantee for enough energy on this if we, you know, go on to adopt this to draft, right?
Yep.
Yeah, let's take that on the mailing list. Okay.
Right. Any? Do you want to do the closing remarks for the work group meeting?
Fine. We have already overtime, and we have very good meeting this week. Thanks all for your time, and hopefully see you next meeting on site or remote. Thanks.
Thank you.
Thanks, Thomas. The meeting, I've got to run off to another meeting and then I'm going to go off to the airport. So thank you for a good flight home.
Yep.
Hopefully, see you.
Yeah, likewise.
Thank you for all your work.
Likewise.